In this next section, we're going to discuss chemicals in the chemistry lab. First, handling chemicals. Chemicals can potentially pose a large safety hazard, so it is extremely important to handle them correctly in order to minimize these hazards. First, never leave the caps of chemical bottles open or lying around. Never remove a chemical from the laboratory. When diluting acids, always add acid to water during preparation. Do not add water to the acid. A separate container should be used to transport chemicals between labs. So if you have like a bin or a tub, you want to put them in that to go in between lab spaces. Appropriate clothing and protective gear should be used for the chemical that is being handled. So lab coat, safety glasses, gloves, sometimes underneath a fume hood or with a face shield. If a large chemical bottle is broken, evacuate the lab due to the fact that the vapors could potentially be dangerous. Always keep chemicals that are flammable or explosive away from ignition sources. Storing chemicals. Different chemicals react, so it's important to store them in a way to prevent this from happening. The two main subcategories that chemicals should be split into when being stored are organic versus inorganic, and I will show you a table of this on the next slide. Chemicals should be stored alphabetically within each family. Flammable chemicals should be stored in dedicated cabinets. We should store volatile chemicals in a ventilated cabinet. Acids should be stored in a dedicated acid cabinet, and nitric acid should be isolated from the rest of the acids and kept in a cabinet designated for corrosive chemicals. On the next slide, we'll go over a list of compatible families for storing chemicals provided by Flynn Scientific. As you can see, we start first by separating into categories of inorganic and organic, and then groups that can be stored together. Okay, so like inorganic acids can be stored together except nitric, which should be isolated and stored by itself. We can store acetates, halides, iodides, sulfates, sulfites, thiosulfates, phosphates, halogens, oxalates all together. Metals and hydrides can be stored together. Organic compounds, those containing carbon, right? So acids, amino acids, anhydrides can be together. Alcohols, glycols, sugars, amines, amides, imines, and imides together. Okay, so when you have a large chemical storage that you're trying to organize, you just have to make sure that you store things together in compatible families and in appropriate storage cabinets. Chemical disposal. There are 4 characteristics that define a waste to be hazardous: ignitability, corrosivity, reactivity, and toxicity. Hazardous chemicals should never be poured down the drain or put in the trash. Hazardous chemicals should be disposed of according to state and local requirements. It is vital that waste containers are always labeled accurately. Waste bottles should never be filled up all the way. A few inches of space should be left at the top. In most schools, you have people that are trained in hazardous chemical disposal, and often as a department, a science department, alongside oftentimes the facilities people, you'll have to go through annual or biannual training in order to make sure that you know these rules for proper chemical disposal. If you're not sure who the person in your school is who handles all of this, I would speak to your science supervisor and find out, just to be on the safe side so that you know that you're always disposing of things properly. Material Safety Data Sheet, or MSDS. It is vital to know as much as one can about the chemicals they are working with. The Material Safety Data Sheet, or MSDS, is extremely helpful in this aspect as it lists important information about the chemical, such as its properties, hazards, and safety precautions. Everyone in the lab should be aware of where these sheets are stored. These sheets include 16 sections, which include things such as composition, stability and reactivity, handling and storage, first aid, firefighting measures, and exposure hazard. Hazard pictograms. Labels will typically include pictograms that indicate the hazards the chemical represents. Here are some useful pictograms to know. Flammability, compressed gases, environmental hazards, health hazard, oxidizers, acute toxicity, skin and eye exposure or something that is corrosive, unstable explosives, or toxicity. NFPA Diamond. The National Fire Protection Association, or NFPA, has developed the NFPA Diamond, which is a guideline to identify safety hazards with chemicals. Different colors represent different hazards, and the numbering scale from 0 to 4 represents increasing hazard as the numerical value increases. So red is for flammability, starting at 0 will not burn, up to 4 where it will burn below 73 degrees Fahrenheit. So keeping in mind room temperature about 72. Blue is a health hazard, where 0 would be a normal material and 4 would be a deadly health hazard. Yellow is reactivity, where 0 is highly stable and 4 is explosive, so may detonate. Look at some of the others. Unstable if heated, violent chemical change, shock and heat may detonate. Okay, so increasing reactivity. And white is a special hazard. So if it's an acid, something that's an alkali, because those alkali metals react violently with water, corrosive, oxidizer, radioactive, or do not use any water with it. Okay, so all of your lab materials will have this diamond on there with these various numbers to tell you what sorts of safety hazards you might be dealing with.